Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about review for solving systems of equations. So here we're given two systems to solve. And let's go ahead and start with the first one. And when we looked at systems of equations, we talked about two different methods of solving the systems. We talked about graphing and we talked about substitution. And so when we're looking to solve this system by graphing, what we want to do is we want to put both equations on the graph. So let's start with the black one, and we're going to start at +1 for the y-intercept here. So these equations are in the form y equals mx plus b. Okay, and here the b is the y-intercept, or in other words, where the graph crosses the y-axis, and then the m is the slope of the line. And that's a key equation because it gives you the information really nicely so that you can graph pretty quickly. So in this equation, the black equation here, we know that the starting point, or the y-intercept, is 1. So that's why we have the black dot there. And then we also know that the slope of this line is going to be an understood +1 there. So we're going to use that information to go up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, and so on and so forth. So that's what our black line should look like. And then with the red line, our starting point is going to be -3. So we're going to start here at the -3 on the y-axis. That's the y-intercept. And then we have a slope of -1/3. So we're going to go down 1, right 3. Down 1, right 3. Or up 1, left 3. Which puts us right there at that point. And then so on and so forth. So when we write these two lines out, these two equations, the solution to the system of equations is where the two lines intersect each other. So here we can see that they intersect each other at this point. And the coordinates of that point are -3, -2. So this is the x and this is the y. So really we could say that x equals -3 and y equals -2. But you typically write your answer as an ordered pair because we're talking about a point of intersection. So that's how you would solve that one with graphing. You could also use that one, but solve it by substitution. And essentially what you would do is you'd say, okay, since I know y is equal to x plus 1, and I also know that y is equal to -1/3 x minus 3, well, then you can take those two things and set them equal to each other, just like y has to be equal to y. And really all you're doing is you're just replacing y with what you know it's equal to. So this y was equal to this y was equal to this, so the two quantities are equal to each other. And then you would solve that equation then for x. So let's look at that, what that would look like. Here you'd probably subtract 1 from both sides. You'd say x equals -1/3 x minus 4. And then you'd probably add 1/3 x to both sides. And you'd get that 4/3 x equals -4. And then you go ahead and multiply by the reciprocal here. So multiply by 3/4 on both sides. And then when you multiply -4 times 3/4, you're going to get x equals -3. So that was one of the solutions we got. And then you could take that x equals -3 and put it right back into there. Well, I should say not there, but you could put it right back into there for x, or you could put it right back in there for x and solve for y. And you'll get that y equals -2. And again, you want to write your solution as an ordered pair here. So that would be your solution. Many mistakes that are made at the end, especially on multiple choice tests, are that students want to flip that ordered pair. They want to write it as -2, -3. So they'll want to write this. And that usually is one of the options on a multiple choice test, is flipping those two. So make sure you're paying attention to where the x and the y go. Let's look at the other system of equations we were given. Here we're going to go and use substitution. And the idea of substitution is you want to get one of the variables by itself so that you can substitute that in for the other equation. So here, I'm just going to go ahead and choose that we're going to get x by itself in this equation here. And so to start that, we would subtract 2y from both sides and say 4x equals 4 minus 2y, and then divide everything by 4. And then you could say x equals 1 minus 1/2 y. Now what you would do is you would basically say, we're going to take this quantity for x and substitute it in to this x in that equation. So you'd want to rewrite the equation 3y plus 15x, so you'd say 3y plus 15 times the quantity 1 minus 1/2 y equals negative 12. And then you would go ahead and solve that equation for y. So let's go ahead and go through that. You'd use the distributive property here, so you have 15, and then use the distributive property here, you're going to get minus 7.5 y equals negative 12. You got plus 3y. And then you're going to combine the like terms, so we're going to say 3y minus 7.5y is going to be negative 4.5y. Still got the 15 equals negative 12. And then you're going to subtract 15 from both sides. And here we would then say negative 4.5y, I'm sorry, is equal to negative 27. And then you take and divide by negative 4.5 on both sides. And so, therefore, y is equal to positive 6. Now, to find the x, you would take that y value, and you would plug that in right here. So you'd put y equals 6 there. And let's see what that would look like. You would basically say x equals 1 minus 1/2 times 6. X equals 1 minus 3, so then x equals negative 2. And then you could write your solution then. We know it's the x is negative 2, and we know that y is supposed to be 6. So y equals 6, x equals negative 2 is our solution. Then you want to write that as an ordered pair. So the ordered pair solution would be this, negative 2, comma, 6. And that would be your answer. You could also use the graphing on this one. However, it'd probably be a little bit more work to do the graphing. But essentially what you would do, if you were trying to graph this and solve it by graphing, you would want to get the y's by themselves and then use those equations to graph and then see where the two lines would intersect. So let's just go ahead and go through that real quickly. Minus 4x from both sides. So again, you want to get y by itself in both equations. 4 minus 4x. Divide by 2 on everything. So you get y equals 2 minus 2x. Here, if you want to get y by itself, you subtract 15x from both sides. And let's go ahead and make this blue. So you got 3y equals negative 12 minus 15x. Then divide by 3 on everything. And so you got y equals negative 4 minus 3x. Okay? So let's look at what that would look like on the graph. So let's start with the red equation. We would start at positive 2 on the y-axis and then go down 2, right 1, down 2, right 1, down 2, right 1. Or you can go up 2, left 1, up 2, left 1. And that would be the graph of the red line. Then the blue, we would have negative 4 as our y-intercept. So we start there, and then we use a negative 3 slope. So you're going to go down 3, right 1. Or, in this case, since I'm kind of out of graph here, I'm going to go up 3, left 1, up 3, left 1, up 3, left 1, and then... well, I caught myself making a mistake there. Here, on this 3x, this should be a negative 5x. So my mistake there. Get going too fast, and that's what happens. You start making mistakes. So here we should have a negative 5x. And let's start again with the blue line. So you got negative 4 as your starting point here. And then you have a slope of negative 5, so you're going to go down 5, right 1, or you could go up 5, left 1. So 2, 4, 5, left 1, and then 2, 4, 5, left 1. That's going to put you right there. And so our line looks something like this. And that makes sense. That makes sense with the solution we're given because we have -2 here is the x coordinate, and then +6 is the y coordinate. So we still have x equals -2 and y equals 6, and therefore our ordered pair solution is 2, -2, 6.